Okay, for number one, this one is a drag and drop. They want you to drag the rational numbers in this column, irrational numbers in this column. So for the irrational numbers, remember there's three key visual indicators that you can look at. The first one being ... that means non-terminating, non-repeating. Okay. The second indicator is a pi. Right, you got 3.14 ... That's a non-terminating, non-repeating number. And then any number that is a square root of an imperfect square. Okay, if it's an imperfect square, you're taking the square root of it, it's going to give you a non-terminating, non-repeating number. So those are three visual indicators. All right, so if we look on the side here, the first thing I see is the pi, right? So pi is going to go in this column. Square root of 8. 8 is an imperfect square. Okay, so that's an irrational number. So square root of 8 is going to go over here. And then the last thing I see is the three dots with this last number here. 2.72135 and then three dots. Okay, and then everything else, if it doesn't have any of these three visual indicators, everything else goes into is rational. Okay, so you have 3.587, 74.721 with the 1 repeating, 5 halves, 0, and negative 11. Okay. All right, number 2. Which two integers is the irrational number square root of 77 between? Or it's irrational, it's the square root of an imperfect square. The next lowest perfect square is the square root of 64. The next highest perfect square is the square root of 81. So you have 8 and 9. Okay, so it's between 8 and 9. That's option B. Number 3, solve the equation x squared equals 49. All right, so something multiplied by itself is going to give you 49. So we know 7. So let's write this. X times x equals 49. Something multiplied by itself is going to give you 49. Well, of these options, we know 7 times 7 gives you 49. And we also know negative 7 times negative 7 also gives you a positive 49. Okay, so there are two possible answers here. You want to click both B and D. Number 4, similar to number 3 in that it's the only thing is it's x cubed. Okay, so we have x cubed. That means x times x times x gives us 27. Something multiplied by itself 3 times gives us 27. So let's try this first option here. What if we put a 3 in for the x? 3 times 3 times 3. 3 times 3 is 9. 9 times another 3 gives me 27. Hey, that x has to be 3. Okay. Number 5, which statement best describes the value of the square root of 12? So if I have the square root of 12, it is between the square root of 9 and the square root of 16. It is between 3 and 4. Okay, so it has to be between 3 and 4. So A and B talks about it being between 2, 2.5, 2.5, and 3. A and B, we're going to go ahead and eliminate those. Okay, we know this is a 3-point-something number. Okay, it looks like it is closer to the smaller integer. It's closer to 12 is closer to 9 than it is to 16. It's only 3 away from 9. It's 4 away from 16. Since it's closer to the smaller integer, it has to be less than 3.5. It has to be less than 3.5. Okay, so what are our options then? We got 3.4, 3.3, 3.2, 3.1, any of those, right? So from here, right, these numbers, 3.1, 0.2, 0.3, 0.4, those are between 3 and 3.5. Okay, so this one you want to choose option C. Didn't move down. Okay, all right, number 6. All right, square root of 144. Square root of 144 is 12. Okay, 12 times 12 gives you 144. Okay. Okay. Number 7, estimate the square root of 27 to the nearest tenth. So you got the square root of 27. The next lowest perfect square is square root of 25. The next highest is square root of 36. It is between 5 and 6. Okay, so it's a 5 point something number. It's closer to the smaller number, so it's going to be less than 5.5. Okay, so the only one, so we know it's 5 point something. Let's go ahead and cross out B and cross out C. It's A or C, it's A or D, and we know it's closer to the smaller one, right? Square root of 25, so it's less than 5.5. 5.2 is less than 5.5. All right, number 8, the square root of 35. So let's find our perfect squares around square root of 35. The next lowest is square root of 25. The next highest is square root of 36. It is between 5 and 6. We have another 5 point something number. Okay, so we know it's going to be 5 point something. It's not going to be A. It's not going to be C. It's not going to be D. It has to be B. It's only 5 point something number there is. And it's really close to the bigger number. Okay, the bigger integer, so it has to be bigger than 5.5, and 5.9 is. Okay, so number 9 says, which of the following sets contains only rational numbers? Okay, so if it's rational, right, it cannot have those 3 indicators of irrational numbers. It cannot have pi, it cannot have the 3 dots, meaning non-terminating, non-repeating, and it cannot have a square root of an imperfect square. Okay, because these are, so we're looking for just the rational numbers. All right, so look at A, it has 3 dots. That's a non-terminating, non-repeating number. Okay, not A. B has a pi, right? So that makes that 5 pi. That's irrational. It only wants rational. And for D, square root of 3 is an imperfect square. Okay, so it cannot that cannot be an option. All right, so the only thing where you don't have any of these 3 indicators, square root of 25 is 5. That's a perfect square. Square root of 81 is 9. That's a perfect square. Okay, so it's C. All right, number 10, the square root of 92. All right, so let's take a look at the square root of 92. The next lowest perfect square is square root of 81. The next highest perfect square is square root of 100. It's between 9 and 10. Okay, so since it's between 9 and 10, there's 3 points that are between 9 and 10. M is not going to be an option. Okay, M is less than 9. All right, so we got a 9 point something number. All of these are 9 point something numbers. It is square root of 92 is 11 away from square root of 81. It's 8 away from the square root of 100. So it's going to be bigger than 9.5. Right, this right here is going to be 9.5. Okay, so since this has to be bigger than 9.5, right, N is not going to be an option. Okay, so it's bigger than 9.5, but it's kind of in the middle between 9 and 10, right? It's not really close to 10, right? If it's not really close to the square root of 100. It's kind of in between, kind of in the middle of 81 and 100. It's near the middle. So P is the one you want to choose for this one. Q is a little bit too close to 10. All right, number 11. Which list shows these numbers in order from least to greatest? Okay, so the first thing we got to deal with is let's get decimal numbers for some of these. I see the 63%. Okay, so let me go ahead and write 63%. We know is 0.63. Okay. Square root of 38. Let's go ahead and estimate the square root of 38. The next lowest perfect square is square root of 36. The next highest is square root of 49. So it is between 6 and 7. It's 6 point something. It's closer to the smaller integer. Okay, and it's really close. Okay, so I would say maybe 6.1 or 6.2. Okay, so let's go ahead and estimate this square root of 38 as 6.2. And then you have negative 19 over 3. So let's go ahead and divide that using long division. 3 goes into 19. I'm going to put a 0.0 after it. Okay, 3 goes into 19 6 times. 6 times 3 is 18. Okay, and I'm going to subtract. 18 minus 19 is 1. I bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. Okay, if I subtract, I keep getting 1 and keep bringing down a 0. Okay, so it's going to be 6.3 repeating. Okay, and it's negative. Okay, so I have a negative 6.3. I'll put a line over it. All right, so it wants from least to greatest. So it wants the smallest out of all of these. Okay, so this is a negative 6.33, and this is negative 6.35. The smallest is negative 6.35. I see that. And then I see the negative 19 over 3. And then I see the 0.63 and then a 6.2. This should be option C. Okay. All right, number 12. Larry has written 6/10 of his book report. Which decimal represents the part of the book report he has written? Hey, 6 over 10, we know, right? 6 over 10, we just want one place after the decimal point. Okay, so that'd be a 0.6. There's one place after the decimal, right? This place here is the tenths. All right, so 6/10 is 0.6. Okay. A square garden has an area of 36. How long is each side of the garden? All right, so we have a square garden. Okay, so all the sides are the same. We multiply the length and the width, which are going to be the same, and we get 36. Right? We know we're going to end up getting 36. This is the length, this is the width. Length times width has to be 36, and they also have to be the same number. Right? 6 times 6 is 36. Okay, so each side is 6 yards. All right, what is the decimal equivalent of 21 over 99? Well, remember here, 99 is special. 999, 999. Okay, so we have, think about 100. Okay, so 21 over 100 is 0.21, okay? But 21 over 99 is also 0.21, but it's a 0.21 repeating. Okay, so that's option B. Number 15, which is the best estimate for the square root of 25 plus square root of 15? Well, we know the square root of 25 is 5. So it's 5 plus this irrational number. Okay, so let's go ahead and get an estimate for that square root of 15. So the square root of 15 is between the square root of 9 and the square root of 16. It is between 3 and 4, and it's really close to the 4. Okay, so it's 3 point something, and it's really close to that bigger number, so it's, let's say 3.9. Okay. All right, so the square root of 15 is about 3.9. So this is 5 plus 3.9. Sorry, I put in 8. All right, 5 plus 3.9, well, 5 plus 3 is 8, and then the 0.9, so you get, it's about 8.9. 5 plus 3.9. Okay. All right, number 16, which of the following numbers is not a rational number? Okay, so it's not so it's going to be an irrational number. Okay, so you want one of those three indicators. You want an irrational number. Okay, you want an irrational number. This is what you want. 3 visual indicators for that. 3 dots, pi, and square root of an imperfect square. 3 visual indicators. All right, so square root of 64, that's a perfect square. We don't want to choose that. Square root of 11, hey, 11 is an imperfect square. We want to choose that one. And then we don't see any of these other visual indicators. Okay, so just a square root of 11. All right, which statement is false? Whole numbers or integers? Okay, so for this one, we have real numbers, and real numbers are broken up into rational and irrational. Okay, within the rational numbers, what do you have? You have integers, whole numbers, and natural numbers. Okay, all right, so whole numbers are integers. All whole numbers are integers. That's true. All whole numbers and natural numbers are exactly the same, except actually, you know what? This one would be true also. This one is false. All whole numbers are integers. Oh, actually, no, it's not, because whole numbers have 0 in them. Natural numbers do not. Okay, so 0 is a whole number, and it's not an oh, we're talking about whole numbers and integers. Sorry, I'm looking at natural numbers. All right, all whole numbers are integers. That is true, okay? So you got your whole numbers, your counting numbers, 1, 2, 3, 4, 5. All of those are also integers. All right, so back on track. Irrational numbers are real numbers. Any type of number is real. Some integers are whole numbers. That is true. Some integers are whole numbers. The positive integers are whole numbers. But this one, some integers are irrational. Look at the irrational side here. Okay, so integers can only be rational numbers. They can never be irrational. So this is the false statement. All right, number 18, which is the decimal equivalent to 17 over 5. So let's go ahead and do some long division here. So we have 5 going into 17, and want to put a 0.0 afterwards and put the decimal right above there. All right, 5 goes into 17 3 times. 3 times 5 is 15. I'm going to subtract. 17 minus 15 is 2. I'm going to bring down the 0. Now 5 goes into 20. 5 goes into 24 times. 4 times 5 is 20. I subtract, I get a remainder of 0. So it's 3.4. All right, which number falls between square root of 25, which is 5, and 5.5, which is 5.5? So which number is between 5 and 5.5? This right here is 6. Okay. All right, so 5 isn't between 5 and 5.5. It's right at 5. It has to be between. Okay, so it's not 5. 6 is bigger than 5.5. 5.5 is not between, right? It is 5.5, so it's not between here. But 5 and 5.0001. That is, it's bigger than 5 and it's smaller than 5.5. All right, last one, fill in the box with the correct symbol. Let's go ahead and estimate this square root of 7. The next lowest perfect square is square root of 4. The next highest perfect square is square root of 9. It is between 2 and 3. Okay? It looks like it is closer to the bigger number, so we know it's going to be 2 point something. It's closer to the bigger 3, so it's going to be bigger than 2.5. Okay, so since it has to be bigger than 2.5, what are our options? We got 2.6, 2.7, 2.8, 2.9. All right, so all of these, right? So any of these would be a good estimate. So any of these is bigger than 2.5. Okay, all right, so this one would have to be option B.